Hello everyone, welcome to today's presentation. Here we'll be discussing on one simple example on surface drainage. Distance between farthest point in the turf covered drainage area with an average slope of 1.5% towards the drain, and the point of entry to side drain is 200 meter. The weighted average value of runoff coefficient is 0.25. Hope you are getting what we are discussing here. So in the earlier presentation we had discussed quantity Q is equal to CIAD. C, that is coefficient of runoff, average value of runoff, capital C is equal to 0.25, and the distance which will be, we'll see in the given points, other not discussing while reading the question. So we'll see the question what he has given first. Next is the length of the longitudinal open drain in a sandy clay soil from the inlet point of the cross drainage is 540 meters. The velocity of flow in the side drain may be assumed as 0.6 meter per second so that silting and erosion are prevented. Estimate the design quantity of flow, that is capital Q, on the side drain for a 10 years period of frequency of occurrence of the storm. The time flow to inlet chart is, they are providing the chart. A rainfall intensity duration curve may be used. So quickly we'll see the given data and solve the problem. So here I have written the given data. Capital C is equal to 0.25, and from the given chart I am calculating the inlet time, small t1 or capital T1. So that based on the average turf 1.5% and the distance 200 meter. So we'll go to the chart and see how we can calculate T1. So here in this given chart, hope you remember, on the top right corner average turf is mentioned, and they have mentioned for 1.5%. so 1.5 to 2% here by mistake, that is printed as 0.5 to 2%, but it is 1.5 to 2%. So you can calculate for 200 meter from the y-axis, and we can check where it cuts. The line is nearly here. We need to see that is for 200 and average turf. So how much is this? It is nearly 33. Hope you are getting for 200 and 1.5%. We have seen this curve and we are getting the time as 33 minutes. So after getting the T1 value, now I will calculate the T2. Is nothing but that is given 540 meters of length divided by the drain 0.6 meter per second, did in minutes and 15 minutes. Next is duration. Total is 33 plus 15, 48 minutes. Next is drainage area. They have given the length, that is 540 meters, and the length of the side drain is 200 meters, so AD is 108 3 times 0 meter square, that is 1,08,000 meter square. Now we can calculate AD. So AD is for every 1000 meter square, it is nothing but 108. Just put the values and get the Q. Before that we need to calculate the I. So for I, he has mentioned the rainfall intensity for 10-year frequency and corresponding to 48 minutes of duration. Here this chart is typical rainfall intensity versus duration curve. Here they have given us the duration and the frequency. Here you can see the frequency lines for which how much period we need to calculate. That is nothing for 10 years. So third line you can see is this 10 years line, sorry, this dotted line, third dot, second dotted line is that, and for 48 minutes of duration in nearly this, so where it cuts the second line. From that we need to check draw to be straight and need to be checked. So nearly that is 70, 50, 60, 70. So in between this distance is 100. So if it is 100, then how much is this distance? We need to calculate approximately. If it comes is coming 20 for me, so it is 70. I am taking 70 mm per hour. So here calculated Q is equal to CIAD. C is 0.25 directly given. I we have calculated from the second graph, 70 divided by 360 to convert in mm per second into 108 with respect to meter square, 1000 meter square. So I'll just quickly revise what we have done. C value directly given. We have calculated T1 from the first graph, knowing the value of average turf and 200 meter distance. 33 minutes we have calculated, and next T2 we have calculated from the length and the with respect to the velocity of flow, that is 15 minutes. Next total duration we have calculated. That total duration is going to help us for the second graph. And next total area, so from that we have converted into 1000 meters square, so 108, and that calculated T with respect to frequency of 10 years. We have calculated I for every that is 70 mm per hour, so that we have converted 70 divided by 3600. So by this we can calculate the quantity of Q. Thank you very much.